So up until now, we've just been doing one-step conversion factors, converting from moles to mass, mass to moles to molecules, etc. Those conversion factors were done in order to set us up for this mass to mass conversion factor. And this is the actual practical use of stoichiometry. Because if you said that you are going to make 6 moles of sodium chloride, how many moles of sodium and chlorine do you need? That's not really practical because I can't walk into my stockroom and just say, oh, I've got 100 moles of sodium. We measure things out in grams, not in moles. So what this conversion factor is going to help us do, let's say that I'm working for a company and I need to make 100 grams of sodium chloride. Well, I would need to figure out how many grams of sodium and how many grams of chlorine do I need in order to make this compound. So this mass-to-mass conversion factor is going to help you do that. So there's a few rules. First, you want to identify the mass quantity that you're starting with. That's always the one given to you in the problem. You're going to use the gram formula mass as your conversion factor. So you're first going to convert from mass to moles. Then you're going to use the coefficients from the balanced equation, and you're going to set up the mole ratio. Because I can't convert from grams of one thing into grams of another thing. I can't just convert grams of sodium into grams of sodium chloride. I need to convert from grams to moles, convert moles to moles, and then if we take a look at step 4, we're going to use the gram formula mass to go back to mass. You're going to check your units and cancel, multiply the tops and the bottoms, and divide. So let's do a practice problem. So the first thing you're going to want to do is you're always going to want to check to see if your equation is balanced. In this case, it is. So that's one step that we don't have to do. So let's read the question. What mass of NH3 can be made from 1,221 grams of hydrogen and excess nitrogen? So what this is saying is we have this many grams of hydrogen. We're going to blast it with a whole bunch of nitrogen. How much ammonia are we going to actually make? So what we're going to have to do is we're going to have to go from the mass of the hydrogen into the moles of the hydrogen into moles of ammonia, then into grams of ammonia. Because again, there's no conversion factor that converts mass of hydrogen directly into grams of hydrogen, of ammonia. So let's take a look. So you're always going to take the number that's given to you in the problem. In this case, it's 1,221 grams of H2. Again, keep your units because now this is where we're going to flip from one species to another. So we're going to flip from hydrogen into ammonia. So again, just like our regular conversion factors, we're going to want grams of hydrogen on the bottom, and we're going to want moles of hydrogen on the top. 1 mole of hydrogen, this is the gram formula mass right from the reference table. Hydrogen is a mass of 1. There's 2 of them, so it's 2.00. So I did this step. Now I need to do this step. I need to do a mole to mole conversion factor. So we have moles of hydrogen on the bottom because that's what we want to get rid of. We want to get to moles of ammonia, so that's going to go on the top. These numbers in this conversion factor come right from the balanced equation. It's the mole ratio. So for every 3 moles of hydrogen, there are 2 moles of ammonia. And then I'm going to finish by now converting. So we did this. Now I'm going to convert from moles of ammonia into grams of ammonia. So moles of ammonia are on the bottom. Grams are on the top. The gram formula mass for ammonia is 14 plus 3. So it's 17.00 and 1 mole. So now I'm going to solve. I'm going to multiply all the numbers on the top. So I'll do 1,221 times 1 times 2 times 17. And I'm going to get 41,514. Then I'll do the same thing for the bottom. 2 times 3 times 1 is 6. The calculator is going to read 6,919. And then I need to sig fig that. All of the moles, so the 1, the 2, the 3, leave those out of your sig figs and just use the grams. And we would get, with 3 significant figures, 6,920 grams of NH3. Okay. Let's take a look at another problem. Again, always check to see if the equation is balanced, and in this case it is. How many grams of aluminum are needed to completely react with 135 grams of iron 3 oxide? So you're always going to write down what's given to you. 135 grams of iron 3 oxide. I need to get into moles of iron 3 oxide. So that's what I'm going to want on the top because that's what I'm going to want to go to. I'm going to calculate the gram formula mass of iron 3 oxide. So iron has a mass of 55.84. I'm going to multiply that by 2. Oxygen has a mass of 15.99. I'm going to multiply that by 3. Add those together and you get 159.65. And that's 1 mole. So now I want to do a mole to mole conversion factor. I want to go from moles of iron 3 oxide into moles of aluminum. And these numbers come right from the balanced equation. For every 2 moles of aluminum, there is 1 mole of iron 3 oxide. And then last but not least, I want to get into grams of aluminum. So I'm going to have moles of aluminum on the bottom, grams of aluminum on the top. If I look on the periodic table, aluminum has a gram formula mass of 26.98 per 1 mole. So now I'm going to multiply all the numbers on the top. 135 times 1 times 2 times 26.98, and I get 7,284.6 divided by 159.65 times 1 times 1. And after sig figging that, you will get 45.6 grams of aluminum. So if I wanted to react with all of those 135 grams of iron 3 oxide, I would need 45.6 grams of aluminum to do so. Okay, so what I want you to do is I want you to pause the video and try this practice question on your own. Oh, this is the same one from before, so let me go to the next slide. Try this practice question on your own. So you're going to pause the video, try it, and then come back and watch my solution. So you're always going to want to see that the equation is balanced, and in this case it is. The question says, how many grams of aluminum are needed to react completely to make 450 grams of oxygen? So you're always going to write down your given. Put that decimal point for sig figs. I want to convert from grams of oxygen into moles of oxygen. So grams of O2 on the bottom, moles of O2 on the top. Oxygen has a gram formula mass of 31.98. 1 mole of O2 on the top. Then I want to do a mole to mole conversion factor between oxygen and aluminum. So I now want moles of aluminum on the top. I'm going to pull down those moles of oxygen on the bottom so they cancel out. So this comes right from the equation. For every 3 moles of oxygen, I have 4 moles of aluminum. So it's a 3 and 4 ratio. And then I want to get to the grams of aluminum. So I'm going to have moles of aluminum on the bottom, grams of aluminum on the top. Aluminum's gram formula mass is 26.98. 1 mole of aluminum, and then I would solve. So 450 times 1 times 4 times 26.98. Is 48,564. And then the numbers on the bottom, 31.98 times 3 times 1, 95.94. After sig figs, you get 506 grams of aluminum. And that's how you solve these mass-to-mass conversion factors.